Hello, good morning, student. Here we are going to study today this electrophilic substitution reactions with chlorine, with bromine, with nitration, and the Friedel-Crafts alkylation and acylation. So let's see. I am going to show you the reactions of benzene. So our objective describe the chemistry of arenes, main benzene with substitution reaction. As I told you, benzene gives always substitution reaction rather than addition reaction because substitution reactions will retain the stability of benzene ring. So we have four types of reactions here with chlorine, with bromine, and nitration of benzene and Friedel-Crafts, the name of scientist, alkylations and acylation. There are two types of reaction. Let's see, we want to discuss about that what are arenes, and arenes are aromatic hydrocarbon, that is hydrocarbon that contain at least one benzene ring. At least one benzene ring. They have higher boiling point and melting point also, and they are aliphatic hydrocarbon. This is because in aromatic hydrocarbon there is a dipole moment. You can say that uh, partial positive and partial negative. Their forces are very strong. So which type of forces? Van der Waals forces. Benzene with the side chain also have permanent dipole forces between them. This is only the information for you that what are the arenes. This very important topic, this one, reactivity of benzene. We want to discuss now that alkenes benzene is the resistance to addition reaction. This is because it involves breaking the delocalized electron system and thus losing its stability. So benzene will not give addition reactions because this is your answer, because it's losing its stability. Instead, benzene undergoes, gives substitution reaction, the replacement reaction, exchange reaction, you can say. This involves replacing one or more hydrogen atoms with another group of atoms. So what are the substitution reaction? When you are going to replace one hydrogen or maybe more hydrogen with a new group of atoms is called substitution reaction. Benzene specially gives an electrophilic substitution reaction. Electrophilic substitution reaction. So what are the electrophilic substitution reactions? First, the electrophilic substitution is the replacement of an atom or group of atom by an electrophile. Electrophile means positive species. Electrophile means positive species. In benzene, the electrophile replace the hydrogen atoms from the benzene ring. Electrophile will replace one hydrogen or maybe more hydrogen as mentioned above with a group of atom with an electrophile. So what is electrophilic substitution reaction? The replacement of an atom or group of an atom by an electrophile. Electrophile, it react, we denote it by E positive, it react with an aromatic ring and substitute of one or more hydrogen. Mean that you can replace one hydrogen, you can replace more hydrogen by replacement with an electrophile. So benzene does not undergo the addition reaction because in addition reaction would yield a product that is not aromatic. First things, that is not aromatic. Second things, you saw here in point number 1, it's they are losing its stability. So benzene will not give addition reaction at ordinary condition. At ordinary condition. Now we are going to start now. What are the electrophilic substitution reaction for benzene? So first you understand what are electrophilic substitution reaction. Then you need to understand what is electrophile. It is a positive species that going to attack on benzene ring and replace with one hydrogen from the benzene ring. Let's see the first example of substitution reaction is aromatic halogenation. Aromatic halogenation. You are going to add either chlorine or bromine gas. So first, for the chemical reactions, here you need to understand what are the requirement of for this reaction. First, you need the reagent, that is chlorine or bromine gas, Cl2 or Br2. Both are halogens, so that's why we call halogenation. Addition of halogen on the benzene ring we call halogenation. What are the conditions required for halogen? Aluminum chloride AlCl3 act as a catalyst, or iron chloride FeCl3, or you can use instead of chloride iron bromide when you write the reaction with Br2. So first you need the reagent, then you read the condition for the reaction, and what is your final product? Halobenzene, mean maybe chlorobenzene or bromobenzene. Let's see here, the point number 2 explanation is given as I told you. So we are going to use here aluminum trichloride to form a chloro or bromobenzene respectively. One hydrogen atom in the benzene ring is substituted by the halogen. Because these all reactions are electrophilic substitution reaction, and substitution we are going to replace one hydrogen with one electrophile. Here electrophile is chlorine or bromine. Use chlorine as an example of halogen. This benzene C6H6, when it react with the chlorine, they will form chloro. Here Cl will attach by the replacement of one hydrogen. Here total 6. Here it will become 5, and then removal of hydrogen with one chlorine, because here we have two chlorine, Cl. So what will happen? This is the benzene ring. Then this Cl will attack on the ring and replace one hydrogen from any carbon. Like here, replacement of one hydrogen from carbon number 1, and chlorine attach itself, and the hydrogen removed from this position will react with another chlorine, and the formation of hydrochloric acid. So this compound actually we have the product is halobenzene. So which halogen you are going to use? Chlorine, so the name is chlorobenzene. Now reaction with Br2, same. This electrophile will attack on the ring. Then in the presence of FeBr3, here in the presence of AlCl3, these two are act as a catalyst or the condition required for this reaction, for chlorination and for here bromination. Because when we are going to add bromine, so we call bromination. So now here bromine molecule Br2 mean Br bond with Br another. So two Br molecule here, one will replace with hydrogen here on the benzene ring, and another will be attached with hydrogen, and we will write HBr like HCl. So this is bromobenzene, this is chlorobenzene. So here you can write this reaction is bromination, and for this reaction you can write chlorination, because here electrophile is Cl positive, here electrophile is Br positive. So when they attack on the ring, positive here Cl, here positive Br attack on the ring, they will form bromobenzene, and here if chlorine, it will form chlorobenzene. This is the first type of reaction. Our second reaction is aromatic nitration. What are the reagents required for nitration of benzene? That is concentrated nitric acid, HNO3. It's the formula of nitric acid. Then condition is the special is condition required reflex at room temperature lower than 50 degrees Celsius temperature, and in the presence of concentrated sulfuric acid as a catalyst. So what is the reagent here? HNO3, nitric acid. And what is the catalyst here? What is the catalyst here? Sulfuric acid. So first, it is a mixture of nitric acid and sulfuric acid. So when nitric acid within a reaction, it will react with sulfuric acid, they form a nitronium ion. Nitration happens when one or more hydrogen atom in the benzene is replaced by a nitro group. So from where we will get this nitro group? From nitric acid. When it reacts with sulfuric acid, so as a result of reaction of these two mixture, we will get a NO2 group. Benzene react with the nitric acid in the presence of concentrated sulfuric acid to give the nitrobenzene. What happened here? What is the electrophile here? The electrophile is NO. Here you can see HNO3 here, HNO3 here. Both reactions are same. This is the presence of sulfuric acid and heating. Heating under reflex mean to avoid evaporations. That's why we call under reflex. So from this nitric acid, during the chemical reactions, nitronium ion will produce. Nitronium mean NO2 plus. That is called nitronium ion. That is the electrophile for this reaction, for nitration, NO2 plus. Sometimes in exam they will write only NO2 plus. That is the electrophile comes from nitric acid, and that NO2 plus will attack on the benzene ring and remove one hydrogen from here and attach, it will attach itself on the benzene ring. So you will get NO2 on the ring. So this NO2 is the nitro group, so we call nitrobenzene. Like here, nitrobenzene. The name is given here, nitrobenzene. And hydrogen from here and one oxygen from here and one hydrogen from here, they will form a water molecules. So formation of nitrobenzene is called nitration of benzene. This is the second type of reaction. Now going to start the third, Friedel-Crafts alkylation. And then we will study Friedel-Crafts acylation reaction. Friedel-Crafts alkylation. First things, the change in their functional group from benzene, it will convert it from benzene to alkyl benzene. The reagent required for this is chloroalkanes, mean any alkane group attached with chlorine in the presence of an anhydrous ammonium chloride catalyst. So what is the catalyst here? Ammonium chloride, AlCl3. Condition required for this reaction, heat under reflex to avoid evaporation. And these types of reaction is called electrophilic substitution reaction. Electrophilic substitution reaction. Here you need to pay attention please. And chloroalkane, because we need the reagent chloroalkanes, can be used RCl, where R is alkyl group, example CH3, C2H5, that you can represent by R alkyl group, and the electrophile is R positive means CH3 positive, C2H5 positive, that is electrophile for alkylation, because you are going to add alkyl group on the benzene ring. That's why we call alkylation. Clear now? Please look at here how formation of electrophile take place when this is the catalyst here, aluminum trichloride. So when aluminum trichloride or AlCl3 react with chloroalkanes, this is Cl and alkane mean here we are going to use ethane. So chloroethane, this name is chloroethane because we have two carbons. When catalyst will combine with this reagent, then they produce electrophile CH3CH2 from here, CH3CH2. Then they will remove Cl ion from here and it will attach with AlCl3. Before it was, now AlCl4 negative. Means that you will get one extra chlorine atoms from chloroalkanes. Now here CH3, CH2 positive. This positive sign actually, CH3, CH2 positive, it is electrophile for alkylation. Maybe if you use CH3Cl, that is only CH3 positive as they mentioned here. If you use CH3Cl, so CH3 positive is electrophile. If you use C2H5 like this, same like this, CH3, CH2 positive, this is electrophile for alkylation. Look at the general example, then we will see. Now, benzene plus RCl. R is an alkyl group. You can see the chloroalkanes. R group will replace one hydrogen from the benzene ring and attach itself in the presence of AlCl3, act as a catalyst. So you can see here, this is alkyl benzene because R is alkyl group. Benzene converted now into alkyl benzene. This is the benzene, it will convert it now into alkyl benzene. And from this position, one hydrogen will react with Cl and they will form hydrochloric acid. So R can be CH3, R can be C2H5 or more, but rest reaction will be remain same. The overall equation for this reaction, you can see we got in this equations electrophile. So CH3, CH2 positive when it react in the presence of the catalyst, plus benzene is the main reagent. When it will react with electrophile, this electrophile will attach on the benzene ring. So attach from which side? Where is the positive sign? CH2. So first CH2, then CH3. So because two carbon, we call it ethyl, and the ring name is benzene, so we call ethyl benzene. Plus AlCl3. Here AlCl4, one chlorine from here will react with one hydrogen from the ring, they will form hydrochloric acid. So in this way, we can call this reaction as alkylation because you are going to add alkyl group on the ring. So ethyl benzene, if you add only CH3 positive, then ethyl benzene. There is more example here for alkylation. CH3Cl, so only CH3 is toluene or methyl benzene. Here the tertiary chloride, you can say tertiary compound C and then 3CH, then Cl. So we can attach C positive and CH3, it will be remain same. This is the electrophile. Just remove Cl from here. You can write positive on carbon and it will attack on the benzene ring. Then the formation of this compound will take place. The name is tertiary butyl chloride because we have 4 carbon, 3 from here, 1 this one, and it will attach on the ring. So you got 3 examples for alkylation. Practice please and you will get the more information. Next we have Federal-Kraft acylation. Before alkylation, now acylation. See the change please. Change in the functional group from benzene to phenyl ketone. Phenyl group I told you before, and now ketone COC functional group. The reagent is acyl chloride in the presence of same AlCl3. Condition required is heat and we need electrophile also. So an acyl chloride can be used RCOCl where R is an alkyl group like CH3, C2H5, and here the electrophile is RCO positive because you just remove from here Cl. Then what left? RCO. So this RCO positive is electrophile for acylation. Look at here how electrophile formation take place when this AlCl3 react with CH3COCl, acyl chloride. This CH3COCl actually is acyl group you can call. Acyl chloride here you can see acyl chloride. CH3CO is the acyl group and if there is chlorine, acyl chloride. Then the formation of this acylium ions. This is called acylium ions, CH3CO positive. So this is our electrophile. This is our electrophile. This is our electrophile CH3CO positive. And when this electrophile attack on the benzene ring, please, I have the online lesson. And when it attack on the benzene ring, this electrophile CH3CO positive will attack on the benzene ring. The formation of phenylethanone. Phenyl, this is phenyl group till before the carbon, this is the phenyl group. Ethanone, because we have two carbon, so we call ethane. O-N-E, because of COCH3. So because this ketonic group, so we call O-N-E. So phenyl ketone, as you saw before, phenyl ketone. If two carbon, ethanone. And this group is called phenylethanone. And this whole reaction is known as acylation. And you will get the more example here. Acetyl chloride with benzene in the presence of AlCl3, you will get the acetophenone. Acetophenone means this CH3 C double bond O will attach with the phenyl group, and then CH3 you can write here CH3. What will happen in this reaction? The new carbon-carbon bond between a benzene ring and the new acyl group will form, and that carbon-carbon bond actually we call phenyl ketone. Ketone can be ethanone, propanone, or maybe one carbon here, two carbon here, three carbon here. So we will write according to that the name of the compound. I hope you will understand these are till Fiddlecraft acylation, and next class inshallah we will start more. Thank you, hope you will understand. Please give me feedback.